Okay, well, good afternoon, everyone. It's 2 o'clock. Thank you for coming and welcome. Appreciate your patience. We did open the room up a little bit early for folks to filter in, so I know I sounded like a broken record for some of you, but again, appreciate your patience. Thank you all for attending this now 4th session of our 7-part webinar series. I'm Mike McGough, Executive Director of the National Corrugated Steel Pipe Association, NCSPA, and I'll be one of your 3 tour guides on our journey here this afternoon. Changes in land use require designers to give careful consideration to stormwater management issues. The development of previously undisturbed areas where changes in land usage and drainage patterns can lead to localized flooding, stream channel destabilization, erosion, pollution, siltation, and sedimentation. All of these negative effects on the environment can and must be avoided by the careful design of an effective stormwater management system. An efficient stormwater management plan considers both the quantity and quality of runoff collected. An efficient and cost-effective stormwater management program may entail a variety of design elements depending on the site conditions, land use, and local regulations. Many of the components used in stormwater management systems can be manufactured using corrugated steel pipe, CSP. Stormwater management techniques can include structural design elements such as detention, retention, flow control, inlet protection, routing considerations, and water quality devices. Using CSP structures for design elements is an effective technique for achieving stormwater quantity and quality control. This webinar, while not intended to be a comprehensive evaluation of stormwater management practices, will examine various effective components using CSP that can be incorporated into a stormwater management program to satisfy most site development stormwater management needs. These webinars are being presented by the NCSPA in partnership with the American Galvanizers Association. And as I said, this is the 4th installment of this webinar series. Future webinars will continue to be hosted every 2 weeks at the same time of 2 p.m. Eastern on Thursday afternoons. Future topics will cover areas such as sustainability, quality and certification, and rehabilitation. Just a quick reminder that PDH and LU credits are available for those participating this afternoon. So please be sure to complete your information and take advantage of this free opportunity. Membership of the NCSPA is comprised primarily of steel coil manufacturers, coaters, and fabricators. The mills or manufacturers will produce and coat the steel sheet coil and then ship it to the various fabricating companies that will in turn roll form, rivet, or fabricate the steel into the various profiles for either pipe arches, or structural plate buried bridges that have been installed under our nation's highway system for over a century. As a quick review, on our first webinar, we discussed the types of coatings available for CSP. These coatings include galvanized or zinc coated, aluminized type 2 coated, polymer laminated, and post-pipe fabrication applied coatings and paving such as asphalt coated and concrete lined. In reviewing each of these coatings, we covered the material specifications that have been developed, the decades of research that has been conducted, and the types of protection they each provide. From the cathodic protection provided by zinc to the barrier coating of aluminized type 2 to the environmentally resilient polymer laminate coating, which results from a strong chemical and mechanical bond developed during the laminating process. Of course, inherent within each of these coatings is its ability to perform in specific environments. Not all coatings are created equal. This table presents the expected service life for each of these coatings based upon the environments in which the products are installed, including pH, resistivity ranges, and the maximum allowable FHWA abrasion level. During our second session, we covered the structural design methodologies used to develop fill height tables for each standard diameter gauge and profile of corrugated CSP and pipe arch, using both the AISI methodology and using AASHTO load resistance factor design LRFD calculations. Now, while there are seemingly countless options out there, the standard mechanical properties of the product allow for straightforward design calculations resulting in fairly consistent fill height tables, regardless of the methodology. Tweaking the knobs on the factors will have some effect on the tables. In most cases, that effect will be realized on the maximum allowable cover. However, this resulting maximum will nearly always exceed the maximum height of the product. This is again calculated by evaluating the ring compression strength of the pipe, also known as a thrust, and by a pipe's ability to withstand bending failure of the pipe wall. Thrust is calculated by combining two factors, the dead load and the live load, and then multiplying that combined load by the diameter, dividing it in half. Pretty simple and straightforward, right? The soil structure interaction between the pipe and the backfill is different for flexible pipe and rigid pipe, of course. Flexible pipe, as the system is compacted and consolidates, will deflect along with the soil, shedding some of the load, while a rigid pipe will actually attract the load. The ratio of the interaction is illustrated on this slide. For a given loading condition, a rigid pipe will likely have to be designed to carry 3 times the load of CSP. Now, why is it important to have bending strength if the pipe is just going to be sitting in the ground covered by dirt? Well, I think we all know the answer to this again. You got to move it around, right? And it's this resistance to flexure that's crucial when handling it in the yard or on the job site. This also comes into play during backfill, most sensitively on larger structures. The structure just simply must have enough strength to resist the distortion. We do not want these structures to rack at all. Now, this slide boils the procedure down into 7 easy to follow steps. First, you must determine the pipe properties. Second, the compressive stresses acting on the pipe wall. Third, the maximum allowable stresses. Then you're checking the handling, installation, or the flexibility factor. Next, if applicable, you will check the seam strength. Then check the minimum cover, required for the pipe. And then if it's a pipe arch, you're going to check the corner and bearing pressures. As we said before, the pipe is completely backfilled and properly supported by the soil envelope. The pipe must have adequate bending stress to resist the shape distortion during handling and installation. As the fill is placed against the pipe, the soil exerts active lateral pressure on the pipe. Additionally, forces are applied to the pipe through the backfill placement and compaction. So there's a certain minimum bending strength that's required to resist these forces. But once the backfill depth over the structure overcomes the active lateral pressure that the soil exerts, the structure becomes completely under ring compression. Now, that depth of cover is typically span over 8, and that's often considered the minimum cover for normal live loads. The design of the backfill for these structures, as we said, is extremely important. Non-plastic sands and gravels are the preferred material. Organic should be avoided. Now, per AASHTO M145, A1s, some A2s, or A3 material can be suitable for these installations. This next slide shows the table which correlates the UCS classification system versus the AASHTO M45 classification system. And here you can see the A1s and A2s that are listed. Next, we talked about installation. Of course, one of the important things about installation is your foundation prep and the bedding. For normal installations, it's important to compact underneath the haunches, and then the foundation itself should be viewed as a cushion for the pipe. It should have relatively yielding when compared to the material compacted around it. The haunches are more difficult to backfill and compact, and sometimes do not receive the adequate attention, so care must be taken to eliminate voids and soft spots. Finally, we move to multiple barrel installations. Here, spacing must be adequate for proper backfill placement, haunching, and compaction. Minimum spacing depends on the shape and size of the structure, as well as the type of backfill material. Minimum spacing can be reduced somewhat when crushed rock or other backfill materials are used that flow easily into the haunch and require little compaction. Spacing can be reduced to 18 inches or potentially less, but when controlled low-strength material is used as backfill, then spacing is restricted to the necessary place the grout between the structures. Backfilling between and outside of structures must proceed jointly to maintain this balanced load. And the room required, desired, compaction equipment should be considered when determining these spaces. Now, y'all have heard enough of me blabbing on and on. For our speakers today, we have with us Mark McCord with Southeast Culvert out of Winder, Georgia. Mark's a yellow jacket from Georgia Tech, graduating with a civil engineering degree. He has over 18 years of experience in the drainage pipe manufacturing industry. He's been an active participant in NCSPA's TAC committee for most of his career. He currently serves as the second vice president of the association. Now, Mark will be talking on the second half of the presentation. He'll be talking about some retention systems, inspection and maintenance. But up next, talk to us and open things up on stormwater management and water quality is Daryl Sanders. Daryl's with member company Contech Engineering Solutions, a Quick Creek company. He's a Bearcat from the University of Cincinnati and holds a BS in civil engineering. Daryl also obtained his MBA from the University of Dayton. Go Flyers. Daryl is a licensed professional engineer in well over a dozen states. He has nearly 30 years of getting your hands dirty, practical, real-world design and construction experience with the full gambit of pipe materials. Daryl served as a committee member of several national organizations, including ASTM, AASHTO, PRB, and CSA. And Daryl, with that, I'll leave it to you.
Well, thank you very much, Mike. Yeah, pleasure to have an opportunity to speak with everyone today. Thank you for your attendance. What I wanted to talk about over the next few minutes is stormwater management and water quality and how those can be achieved through the use of underground detention systems, specifically those constructed using corrugated steel pipes. So, why do we want to detain water? Most urban agencies have a requirement that the runoff created after a property is developed does not create any more runoff or impact to the local watershed than it did before it was developed. So when you go in and you build buildings and you build parking lots and create a lot of impermeable area within a site, typically that would create more runoff that would go into the local streams and storm sewer systems, and could tax those systems and render them to be insufficient. So, in order to overcome that, most agencies will say that you have to design your development such that the runoff after the development is completed does not exceed the maximum runoff that was on there pre the development. So The detention system is just simply a way to capture the water that falls on the impervious areas within the site, place it and store it underground in a series of interconnected pipes that have flow controls on the outlet to limit the maximum discharge coming out of the system, so that those discharges do not exceed what was allowed or what was coming off the site pre-development. So that's the basic impetus for the detention. And you can either detain the water, or you can also recharge the local soils with the stormwater as well, and use that for storage. Mark will be talking a little bit more about those kinds of systems later on in the presentation. I'm going to focus primarily on detention systems, and you can see here this is a job site that has a pretty extensive system. We'll talk a little bit more as we go along about some of the particular features and benefits of using corrugated steel pipe in these applications. So why go underground? Well, obviously one is to limit the amount of runoff coming off, but that can be done in a number of ways, including surface ponds and other means of storing the water. But by going underground, you can maximize the amount of usable land. Ponds can take up a lot of surface space, and renders that space unusable for other activities, whether it's a parking lot, whether it's storage, whatever the case may be. So by going underground and storing the water underground, you can maximize the usable land space on your site. You can eliminate potential pond safety issues. You can eliminate some vector control problems, primarily mosquitoes and so forth, from sites by storing underground and limiting the amount of surface water that's standing on your site. And also it makes the systems more contained, easier to inspect and maintain. In terms of what material choices are available when you choose to use an underground detention systems, there are a number of systems that are out there and available, but some different things that you might want to take into consideration when you're making your material choice in regard to what you want to use at a particular site. These are just a list of some of the considerations you might want to take in account of. Obviously, the height of cover that's available, the amount of available depth for a gravity flow system coming off of your site. That'll kind of dictate the combination of those two will kind of dictate the maximum size of the storage units that you can place underground. The available footprint that's available on a site. A lot of sites have a lot of constraints, whether it's buildings, parking garages, other utilities that have to be worked around. So taking into account the available footprint that you have for being able to go and utilize an underground detention system, maintenance, total installed costs, the storage volume that's required for your site, the service life that's required based on the site conditions, the soil type of the local geology, the loading that's going to be subjected. So whether you're just at a common parking lot like at a Walmart or Home Depot or something like that, or whether you've got an intermodal facility that's going to regularly have large traffic running over the top of it. Obviously, those kind of considerations could dictate some of your choices, and then of course groundwater levels as well. So in many cases, corrugated steel pipe can be the go-to material for underground detention. And that's primarily because of the economics associated with corrugated steel pipe detention systems. First of all, corrugated steel pipe has a wide range of sizes that are available, diameters anywhere from 12 inches in diameter up to 144-inch diameter. Allows you to maximize the amount of vertical space that you have for storage within your site, and of course, you know, the volume that can be stored as you get into larger and larger diameters is what plays into a lot of the economics that corrugated steel pipe has to offer. There are also different shapes that can be used if you have some site constraints. There are pipe arch shapes that are also available, as well as arches and other geometries. And there are a number of different corrugations and coatings that can be used in order to meet the service life requirements. The NCSPA has a service life calculator and recommendations for the different coatings that are available, and can easily provide a 75+ year service life for the vast majority of sites that are out there. And we'll talk a little bit more about some of the various pipe coatings, but the primary ones that are used for these applications are aluminized steel type 2, galvanized, and polymeric coated pipes. Another thing that provides an advantage to the use of corrugated steel pipe in these kinds of applications is that they can be fully perforated for applications where, you know, you want to use some of the available volume in stone storage around the system. That can be used, and also for recharge systems where the local geology will allow you to recharge some of the site soils in those areas. You can do full perforations or partial perforations easily and economically with corrugated steel pipe systems. Fabrications are no problem whatsoever for corrugated steel pipe. The ability to cut and fabricate allows you to have inline risers, Ys, Ts, manifolds, and bulkheads. So just about any need you would have in terms of fabrications on a site can be accommodated and custom built specifically for your location to minimize the amount of other structures that have to be constructed in order to utilize one of these systems. You can have integrated risers to eliminate concrete manholes, and have the advantage of a faster speed of installation, as well as decreased cost by taking advantage of those. And also many different types of outlet control devices can be incorporated within the system, eliminating the need for a separate structure. So again, a lot of times outlet control devices would be placed into a manhole at the end of some other types of systems. Those can typically be directly integrated within the corrugated steel pipe system. Weirs or other flow controls can be fabricated directly in, thereby saving time and costs for those systems. They're also highly customizable. You can kind of see a photo here of a project in Minnesota where, because of the site requirements, they had to put some horizontal bins within the barrels. So you've got the multiple barrels, but also the fabrications that allow that storage to kind of conform to the available site footprint that the job site would allow. So it is highly customizable, and can also accommodate very high loads and high maximum covers if your site has those conditions. We talked a little bit before about materials and coatings. Again, aluminized steel type 2 is probably the most economical. It has a very wide environmental range where it can provide anywhere from 75 or 100 years of service life. Galvanized steel is still the most commonly used coating because it does have a very wide environmental range and can provide anywhere from 50 years plus in terms of service life. And for particularly challenging sites that have very aggressive environments, polymer laminated pipe can also be provided, and that's what's shown in this photo, and that can provide a that, and I think this also has an asphalt coating that was post applied to it. But the combination of all the different coatings that are available allows you to choose the one that's most appropriate for your particular site. And we talked about, I think Mike actually showed this slide a little bit earlier, but does give the environmental ranges and the service life expectations for those different materials, based primarily on the environmental factors, the pH and the resistivities associated with the soil and water for a particular site. And this also has the abrasion levels, but of course abrasion is really never an issue with detention systems, just because there's really no significant velocity through the system. Here's just another photo showing some of the customizable features of corrugated steel pipe. Here we've got a manifold and a number of pipes that are coming off of it, and the pipe lengths are staggered to create a geometry that again fits the site conditions. So this is actually very easy and economical to do with corrugated steel pipe. With a lot of other systems, it's just more complicated in order to get it into some of these more specific geometries. So you can see here some of the fabrications. You've got an inline riser that the gentleman is standing next to replace a concrete manhole structure, which might be used on other systems. And then you can see the fabricated bulkheads with the reinforcement attached already to them. So when it delivers out to the job site, you can set those pieces with the fabrications and the bulkheads on them, just like you would any other piece. So it does not slow down the installation process at all. And we can also we talked about outlet flow controls, but you can also use pretreatment options with these detention systems as well, to try to capture pollutants, or for some agencies they require you to limit the amount of pollutants that come off of a site. Obviously, sediment control can be achieved within the detention system itself, but for some agencies they have other pollutants. They have requirement for the removal of other pollutants, and with the detention system, the use of pretreatment can be effectively used to remove floatables, sediments, and also some other contaminants before it ever gets into the detention system. These are typically done in manhole units, although there are other systems that are available. Sand filters and others are used in some locations. But pretreatment can be an effective way to help mitigate the pollutants before they get into the detention system, thereby limiting the amount of maintenance and entry into the detention system. And if sediment control is the primary pollutant that needs to be controlled, the detention system itself can also provide that water quality service. And again, you can put in sumps and other features within the detention system to help capture and remove those pollutants over time as a part of the maintenance of the overall system. And this is just an illustration of kind of a common manhole-based pretreatment option. Essentially, it's a hydrodynamic separation. You've got screening that goes on to remove any kind of floatables and neutrally buoyant debris. There's a sump at the bottom for capture of trash, pollutants, sediments, and then obviously flow controls for inlet and outlet. But this can be used to effectively pre-treat the water before it goes into the system, into the detention system. And again, sediment control can be achieved with just the detention system itself. But if you've got other needs, these kinds of systems are common and can be used as part of a treatment train that the detention system would be a part of. And again, this is just a photo of kind of a common corrugated steel pipe underground detention systems. It includes the coupling of a number of parallel runs of pipe through common manifolds at each end of the system. The pipes are placed in close proximity to minimize the footprint and maximize the amount of storage that's available within that footprint. The pipe diameter is generally maximized to again limit the overall footprint required for the detention system. And again, you can see some of the prefabricated manifolds, some of the risers, all those features just help speed the construction and minimize the cost of the overall system. And with that, I am going to turn it over to Mark McCord with Southeast Culvert.
Afternoon, everybody. Like Mike mentioned earlier, my name is Mark McCord. I am with Southeast Culvert. We are out of Winder, Georgia, close to beautiful Atlanta, Georgia. So hope everybody's having a wonderful day. I got my children out of here, so you can't hear them screaming in the background. But I'm going to talk to you today a little bit about retention systems, and I'm going to do a presentation no-no here in just a minute because I think a lot of people use the word retention system and detention system interchangeably. So I'm going to read the definition to you so that we understand really the difference here. I mean, because typically with detention systems, you're employing an outlet control structure in order to slow the water down to pre-developed release rates. But with a retention system, it's a below ground infiltration structure. The purpose of a retention system is to retain on site any increase in post-development versus pre-development runoff and allow the volume retained to infiltrate into the surrounding soils. This allows for recharge of underground aquifers and prevents downstream flooding. Retention systems can only be used where there is adequate soil porosity to allow for infiltration in a reasonable period of time. And these systems are really great for low impact development design. One thing I want to mention after reading that is that obviously location is really everything with a retention system. Down here where we are in Georgia, we have a lot of clay soils, so it's really a 50-50 shot down here as to whether you can infiltrate or whether you can't. And then also in there, we mentioned a reasonable period of time. Typically, that's about 24 hours. You want to see your infiltration within a 24-hour period. So I'm just going to talk a little bit about the design of these types of systems, how it's a little bit different from detention. But it is very similar in the design concept, except for the addition of the void space and the backfill that we're taking into account and the permeability of the soils. Obviously, all of these pipes are going to be perforated. So when you're selecting your required detention volume, it really depends on whether you are using an outlet control structure that is going to replicate the pre-development discharge. So if there is no outlet structure, your retention volume is going to equal the total area under your post-developed hydrograph. If there is an outlet structure, then your volume will be the difference between your post-developed and your pre-developed hydrograph. So these are just a couple places you can start. If you're trying, you want to decide the size and the diameters of these. One way to look at it is you can start with your inlet invert elevation, or you can start with the elevation of your infiltration bed. This is kind of where I prefer to start. I typically define my outlet elevation and then work upwards from there to my minimum cover, which is the next one, because obviously you want to make sure that you do not get within your minimum cover. You don't want a 96-inch system with 3 inches of cover on it. It's just not functional. And then a lot of times you're defined by the area that you have to put these systems. So you might have to get a little creative with it there. And then also the depth of the water table. Obviously you can't infiltrate into standing water. So you have to have a good idea of where that is so that you can start above it. One thing I want to point out here, Daryl kind of talked about it earlier, but if you look in the upper right-hand corner, that is one of our prefabricated outlet structures that you can put into these systems. And with a detention and a retention, you can get pretty much as creative as you want. And I throw these two pictures at the bottom just so you can really see some of the stuff you can do. That's a fairly large system. That's a 12-foot diameter system, but we actually stacked two on top of each other in that application in order to achieve the volumes that we were after. Obviously, we had a huge outfall on that project, but you know, pretty much anything you can think of, we can probably figure out a way to make it. So let's talk a little bit about the design procedure. One, you want to choose your pipe diameter. And really your diameter is going to be defined as the difference between your inlet invert minus the elevation of your infiltration bed. You also want to verify that your minimum cover is met. In these types of situations, really the larger pipe you can put in there, the less expensive it's going to be. Hey-oh, somebody's moving around on me. All right, hold on. Something seems to be going on here, but we'll work through it. The largest pipe that you can put in there is going to be the most cost-effective way to do it. And if with these types of systems, you're typically incorporating some type of stone. If you haven't seen what's happened to the cost of stone since the green infiltration movement has come about, you need to check it out. So typically that's what I try to do, is to eliminate as much stone as possible. Step two is really to define your surface area and your storage capacity. Your surface area is just the ratio of your center to center pipe spacing divided by the storage capacity of the pipe and the void space. This really just, you know, verifies that you have enough infiltration area within your system. And your void space will vary. 40% is typical. That's pretty much a uniform graded stone. But if you happen to go to a well-graded stone or something closer to a sand, your void space is going to vary. So typically your suppliers can tell you what that's going to be. And then you also have to define what your storage capacity is, and that's going to be the capacity of your pipe plus your total void space. So then your third step is to determine the length of the pipe that you need. And that's pretty simple. You take your total retention volume that you need and you divide it by your storage capacity, which again is the capacity of your pipe plus your void space. So once you have that, you really have to look at how much length and how much width you have. And your pipe length is going to be basically the total length that you have minus your overcut minus your header width. And then your system width is going to be your total width minus your overcut. And then from there, you really just have to start playing with the system to see how many you can get in there. And so the number of laterals is really just, you take your length and your available length and divide that into your total length, and that's how many laterals you're going to have. Obviously, you want to make sure that that will fit into your available width. I do want to mention, since I've been going through all of this, all of these examples are actually examples in our design manual. I didn't throw all of that in there because nobody just likes to sit there and look at formulas. So if you're ever interested, you can just you can look through our design manual, and all of those are available there. But your final step is really just to make sure that your volume checks out. And so what you want to do is take your total pipe capacity plus your void capacity and make sure that that exceeds your total storage volume. And once you're there, once you exceed that, you're good to go. I do want to note that with these systems, they're all typically wrapped in a geotextile fabric on the outside of the stone. That really keeps the fines from the exterior soils from migrating into your void space. which would affect your overall void, your void volume, which would be detrimental to the system. So now I want to talk a little bit about inspection, operation, and maintenance. This is a question that I get quite a bit, typically from municipalities, cities, counties, is how do you maintain these types of things? Because it's become a big deal. Most cities and counties now will require a maintenance contract up front before they'll CO a building. So really the key to maintenance is inspection. You want to go in and make sure that you're not getting excessive sedimentation or debris gathering in the system on a pretty regular basis. But you do want to watch because from year to year, your sediment infiltration will vary. I mean, if you take the example down here where we are, just because I'm familiar with it, we've had a couple of really rainy years, so inspection needs to be high. Before that, we were in about 5 years of drought, so we didn't have all of that sedimentation movement. So we didn't have to do as much maintenance during that time frame. So it varies, but so we ask that you probably look at them probably quarterly. For more northern environments, you probably want to check them out a little more during the winter months, where you can have a lot of sanding on the roads and things like that, and you can get pretty rapid accumulation within the system. And then the systems need to be cleaned once you find that sediment or trash have accumulated and they may be clogging one of your discharge orifices. And it's always good to keep a log. That way you know when the last inspection was, and then you can also keep track of what you saw before. So that you do know when it is time to maintain them. So typically, yearly maintenance is suggested. It may not be necessary, but it's just kind of a good rule of thumb. And then we always say wrapping these pipes with a geotextile. One, it can ease your maintenance, and two, it can really prolong the system or prolong the life of a retention system. Minimum pipe diameter is very important. If you've never been inside of a 36-inch pipe, you need to try it. It'll change your life. Being a man of average height, I don't like to go into anything less than a 72-inch pipe. One way to really keep things confined is to put 4 bays around your inlets. That keeps your larger trash and sediments in one place. And then having manholes about every 100 feet. That really just allows for good access to these places and makes it a heck of a lot easier to maintain them. And then also access over your inlets and your outlets, so that you can see that those ways are clear. And typically you're going to need a vacuum truck to remove the debris once maintenance time does come. And you can see from the picture, I took this one myself, you can get down into these things, and after a while you can get some pretty heavy accumulation. So these are just a couple of pictures of ways that you can really prolong your maintenance cycle. If you look on the left up there, those are 4 bays around an inlet to keep the debris in one place. Or like the picture on the right, where you have areas that were specifically designed for the water quality volume with manholes, so that you go in and maintain those areas specifically. You can see that in those areas we also wrap the pipe with a fabric for maintenance purposes. I'll talk briefly about this. Daryl didn't really touch on these, but this is a prefabricated corrugated steel stand filter. These types of systems have been around for a very long time. They're pretty easy to design, and they're very effective on the water quality side. But with these, you really need to have a detailed inspection and maintenance log, because you need to really document what you have in there so that you know when these things need to be maintained. These call for a vacuum truck. They also call for high pressure water. But a lot of times what you can do is you can put a geotextile over your filter media, and that will help prolong the life of these systems, because that can be removed, which removes your bigger debris and your bigger sediments. And then where can I get more information? Voila, your design manual. This is available for download on our website, ncspa.org. Or if you're close to a local manufacturer, I'm sure that they would love to give you a hard copy for free. I think I'm supposed to turn it back over to Mike McGough right here.
Sounds good, Mark. Thank you very much. Daryl, thank you. Good information, guys. Really appreciate it. So yeah, as Mark was saying, all the information that we've presented today can be found in the design manual. In particular, this information comes from Chapter 6, Stormwater Management and Water Quality Design. But all the information that we presented on this in the previous webinars can be found within. Of course, we have online access for the website. Here, this is a quick screenshot of the home page and everything that you can access from the home page. You can do one quick download on the design manual, a link to the webinar series itself. All of the past webinars are available there, both in a PDF as the PowerPoint presentation, and then the videos themselves can also be viewed there. So you can go back and relook at some things if you want to recap more. One other item of note on the homepage is, and Mark really walked through this, is the calculator that we have, Water Quality System Design Calculator. So now Mark walked through the steps involved through his part of the presentation, what's involved in the data that's required to input within this calculator. So inlet and outlet elevations clearly, and then this is where we differentiate whether it's a detention system or a retention system. A solid system would be a detention system. Perforated system, as you said, would be a retention system where you would enter in a void ratio. Then you have the volume required for the system. Whatever the controlling dimension may be for your given site considerations, input that controlling dimension, the number of headers that you'll have, and then the thickness. So that'll get you started. And then, what that'll do is that'll give you a maximum diameter. You can select your preferred diameter. This will give you the storage capacity per linear foot of that diameter of pipe based off of what you input above, and that diameter will give you the spacing center to center and edge to edge. There'll be some quick calculations that it'll run through for you when you try to view the results, and that'll estimate the number of laterals for you. So in this particular example, it estimates at 7, and then you can enter in the actual number of laterals that you have or would prefer. It'll run through the calculations and give you your total volume of cubic feet and whether or not it meets your calculations and your job requirements. So all of that. And then I don't have a screenshot of it, but there's the ability to create a report at the bottom. So again, that's available on the website. And just like all the other calculators, there are apps available for each, both on Apple and Android platforms. For more installation information, you can download our installation manual. Here are the 11 basic considerations to think of, but that's also available as a PDF download. And of course, we have projects. We have lots and lots of projects where you can see these in real life. So of course, our Find a Project page is here on the right-hand side under the newsroom. It'll pop up a nice map for you. And each of these dots denotes a project, as we had discussed before. You can, however, go in and filter. So you can filter by detention and retention. I don't think this actually did the filtering out just yet on this search. But there are probably 25 to 30 detention projects contained on the website. I'll walk us through a couple. I know Daryl showed us some and highlighted some of the customizable variables. But here we have our most recent project of the year winner. This is a West Broad Village detention system in Glen Allen, Virginia. Similar to the one Daryl showed, this is a trapezoidal layout, as you can see. An 84-inch diameter recharge system produced by Lane Enterprises. Another quick shot of the system itself as they lay more pipe. So as you can see, they cut it in a trapezoidal. So this is for an assisted living home, I believe. Now size. So massive size. 100,000 cubic feet detention system here in Cornelius, North Carolina. So 144-inch, 12-foot diameter pipe was used in this particular installation. There's a YouTube video of it. The link is included here in the presentation for those who want to download and look at it in the future. And this was produced by Southeast Culvert. This gives you an overview shot of the project itself. I believe they were a condo building that was going up somewhere in this vicinity, and the detention system was going to be over here. Next is Quick Trip Convenience Store. So another pretty large installation in Kenosha, Wisconsin, 65,000 cubic feet. The nuance on this one is 60-foot lengths were used to limit the joints within the project. And then this was designed for a 40% total suspended solid removal. So there were some, of course, some requirements on the removal of solids within it. Here's another picture of the long lengths that were used. So you can see this is a 60-foot run with just one joint really between the two. So easy access. And then this one here in Griffin Farms is in Lake Mary, Florida. The city required the use of CDSs and separators for this particular project. So I think this is actually a screenshot of what Daryl had showed earlier. So, again, this was a massive project, very well done, very well executed. And the final one we have here is a DLA troop facility outside of Philadelphia. So this particular system was in a pretty aggressive environment, so the polymer coated material was required. But the big selling point on this particular project is it was over 60%. I think it was about 64% on the cost savings from the original structure. So, I think it amounted to somewhere in the neighborhood of $350,000 on that particular project. So, these are very, very economical solutions in most cases. Here's one more picture of that installation. So with that, gang, we're running out of time. Thank you. Here's where you can find us on social media and the like. Of course, we have another webinar coming up in 2 weeks. Our friend Wade Wilcock with Corrugated Steel Pipe Institute out of Canada will be our guest speaker there, and we'll be talking about sustainability on that particular webinar. With that, we can wrap it up and answer any outstanding questions that may still be out there. Let's see, are there any in the chat? So let's see, I see our water retention depths below the frost. So basically our detention below the frost line. Mark and Daryl, you can also offer some input here if you want, but are there concerns with the water at all freezing inside these detention systems? I wouldn't think that would be the case, right?
I live in Georgia. We don't know what frost line is.
Fair enough. Fair enough.
And I'm not sure if Daryl can tap in now.
Oh yeah, he's listed as an attendee. Tapping in now. Yeah, there you go, Will. Will says, ask the Canadian during the next presentation about Frostline. Let's see. Will asks, how does long-term maintenance factor in? Cost, disruption, etc. Yeah, I mean, Mark touched on that a little bit. You know, maintenance of these systems is more just access and making sure that they're cleaned out and you know, not clogged up is primarily what you're looking for in that case.
Yeah. Can you hear me, Mike?
I can hear you, Mark.
Okay. Yeah, I mean, with your detention systems, you know, they'll put a time frame on or you know, a suggested time frame on maintenance, but most of the time these things are so large, you see them going years and years and years before you have to have any type of maintenance go on within them. And there are companies out there now, because these things are used so often, that do this professionally. So the cost is pretty minimal when you look at it over a time frame.
Okay, thanks for that feedback.
Yeah, Eric right here just asked about ventilation for confined space entry. Yes, you do have to have ventilation within the systems for confined space entry, and you do have to follow all the OSHA requirements in order to go in and maintain these things.
Yep. Yeah, and then, you know, Daryl's explained in the chat room that as long as these systems are below the frost line, then freezing is not an issue, right? Most of them are, or would be. Yu Chen asked, do people use HDP or other types of plastic pipe for detention? Sure, Yu Chen, they can, but we recommend that you use corrugated steel pipe for your detention and retention needs. Thank you, Daryl. Well, gang, if there's nothing further, we got 2:58. I see Daryl's typing something else here in the chat room. We can give him another minute or two. Yeah, diameters for HDP are more limited. Certainly up to 60-inch, where, yeah, we can go up to 144-inch. Very good point, Daryl. Thank you for that. All right, gang. Well, if there's nothing else, appreciate your time this afternoon and joining in, and we'll look forward to seeing you all here in a couple of weeks. Take care, everybody. Be good.